Hi, today I'm gonna show you how I will build a Rratt clone. I'm gonna be pretty faithful for the most part, but I'm not gonna go crazy. I'm gonna change a few minor things here and there and then propose one major modification. So let's get into it. So first of all, I'm gonna go over the schematic. This one I downloaded from electrosmash.com, which has an amazing analysis of the whole circuit, so I highly suggest you go and read their article if you are really interested in how the Rratt works. Anyway, first of all, I'm gonna go over the schematic and see what components I can and I cannot get. Then I will propose some changes. Then I will go and check if I have everything I need in-house and maybe replace some small things if I don't have the exact measure of a capacitor or resistor. And once I gather all the components and I finalize the schematic, I will get to build the circuit on a proto board. So first of all, the original Rratt is based on a LM308 op-amp, which I cannot find anymore. One of the peculiar things about this op-amp is that it's pretty poor, meaning that it has a really bad slew rate. That in turn gives it a characteristic sound and distortion. That said, I was never able to find an LM308, so instead I'm gonna go ahead and use an LF353, which, if you have seen any of my previous video, it's one of my favorite op-amp. Always deliver, nice crunch, love it. So because we are gonna switch to an LF353, we are not gonna need this cap here. Also, what's gonna happen is we are gonna have one extra op-amp unused, because in the 8-pin LF353 we have two op-amps. So what I was thinking of using the other half of op-amp to just buffer the 4.5 volts we get from this voltage divider. I don't think it's gonna make a huge difference, but in this way we can make this cap bigger to have a cleaner 4.5 volts, and we don't have to fear to influence the tone of our signal. So I'm gonna go ahead and make this 1 microfarad to 47 microfarad. Yeah, it's huge, but I know I have it in house. Then I think I'm gonna go ahead and change the power supply section to the usual power supply I use in ZenZero's pedals. I usually have a 19 ohms drop resistor, but instead I have a way bigger filtering cap, which is usually 330 microfarad. It's one of the big one you might have seen in my pedals. Also, I'm gonna change this simple diode to a zener diode, a 10 volt zener. What does this do is that it still protects from inverse polarity. So the normal diode is put here so that if you plug your battery the wrong way around, the diode is gonna short. So you risk of burning out the diode, but you're not gonna get any opposite voltages to the rest of the circuit. By changing the normal diode to a zener at 10 volts, I'm still gonna protect against reverse polarity, but I'm also gonna protect against over voltages. If by mistake somebody plug in a higher voltage, the zener will break the voltage around 10 volts and absorb every excess voltages. That's gonna be helpful because the other thing I plan to change in the schematics are this MOSFET. Instead of using this MOSFET, I'm gonna use the one I use in all my ZenZero pedals. It's a double MOSFET that comes in a IC package. Now, I'm not gonna reveal what it is, it's the only thing secret about my pedals, but let's just say it doesn't behave well with voltages over 10 volts, and it sounds great, and that's why I'm using it all the time. You can substitute it with any other MOSFET, and I think you're gonna get pretty similar results. So this one is gonna be 1/2 of my MOSFETs. Because I have one more MOSFET, I'm gonna go ahead and do a slight modification to the output section of the Rratt, which is notoriously known to be a bit on the weak side. I wanna get a bit higher volume. So the first MOSFET, I'm gonna use it just like this, like a buffer. But then when we get to the second one, I'm gonna make a few changes. So I'm gonna cut the circuit here, and I'm gonna borrow a few ideas I used before in some of my ZenZero pedals. So first of all, I'm gonna have the volume, but this volume pot is gonna be half of a double pot, and it's gonna be just a 10K linear resistor. I'm gonna come out from here, and then I'm gonna go to a really simple output booster. It's gonna resemble a bit of a super hard-on, if you ever saw one, which is a really simple circuit made with MOSFETs. So we're gonna have a 10 meg resistor to ground. We're gonna have a 10 meg resistor as a negative feedback and biasing resistor. That's gonna go to here. Then we're gonna have a 10K resistor to our plus 9 volts. We are gonna then come out from here. I'm gonna put here a 10 microfarad output cap, just because I like to have a bigger cap on the output because I don't know what's gonna follow. I'm gonna have a 100K resistor to ground to discharge this cap and probably prevent pops. And then we are gonna go out. So basically we are gonna skip this volume. We are gonna replace it with this. Now for the source of the MOSFET, as in the super hard-on, we are gonna have a changing biasing resistor here, and that's gonna change the overall gain of a stage. What I'm thinking of using is I'm gonna put the other half of the volume pot. So I'm gonna shorten half of the pot, while the other half of the pot is gonna serve as our variable resistor. And because this is gonna be 10K, I want it to behave a bit differently. I'm gonna put it in parallel to another 10K resistor. So we're gonna have a maximum 10K parallel with a 10K resistor. This is gonna change and go down to 0 at our highest settings, and then I'm gonna just add one more resistor so the overall biasing of a transistor doesn't drop to exactly 0. I'm gonna put a 681 ohm resistor here. So the overall gain of this MOSFET stage is gonna be the ratio between the drain resistor and the overall source resistor. So it's gonna be 10K divided by what we have here. And what we have here is a parallel between the pot and 10K plus 681. So when our pot is gonna be on the lowest setting, we are gonna be something like 10K parallel with 10K plus 681, which makes 681, which is a bit less than 2 of gain, because we have to do 10K divided by this. We're gonna be 10K divided by 3, and it's gonna be about, I don't know, 0.9. I don't know. When our pot is gonna be at the minimum, which is gonna be the maximum volume, we are gonna have just 0 parallel with 10K, and so we're gonna only have 681, giving us 10K divided by 681, which makes, you tell me, almost 15 actually. So a maximum volume setting, we are gonna have a 15 per boost. In the middle, when our control is gonna be at 12, we're gonna have a loss of 1/2 of the volume from this pot, the first pot, which makes a voltage divider. So when it's set at 12 o'clock, we are gonna lose half a volume here, and then we are gonna multiply it by, so you're gonna have 5K, because the second pot is gonna be parallel with 10K plus 681. So we're gonna have a 3.333K equivalent resistor plus 681, which makes, let's say, about 4K, and as the amplification factor is 10K divided by 4K, we're gonna have a 2.5. So we're gonna lose half volume here, but we're gonna boost 2.5. So around 12 o'clock, we're gonna have just a little bit more than the maximum of original Rratt. Over that, from 12 o'clock onward, is gonna be all boost. So now, what I'm gonna do, I'm gonna go and check if I'm missing any of these components, and if they're not missing, I'm gonna start building. So I think I found everything I needed to build the pedal. Here are all the components I gathered. I had to change only a couple of places. I didn't have a 560 ohm resistor, so I'm going to use two 1.07k in parallel. I also didn't have a 3.3 nanofarad, so I'm going to use a 1 nanofarad in parallel with a 2.2 nanofarad caps. Also, I didn't have 1N914 diodes. I'm going to use 1N4148 diodes. And I forgot a cap here. I normally would make it 47 nanofarad, but I went with 22 nanofarad, as it seems to be the standard in this pedal. And that's it. Now, what I will normally do if I was planning to make this a ZenZero pedal is, first I will breadboard it, and secondly, and more time consuming, I will work on the tone stack and on the overall tone of the pedal. This is just a one-off, I think, so I'm just gonna go straight and build it on a proto board. Hopefully everything is gonna fit on it. I started out by measuring up my components and then making a simple design, which then I printed out on the car. The decal I use here is one I printed out with my laser printer. It's not actually as good as the one I used to print with my inkjet printer, but anyway. Then I fitted all the components inside to make sure everything's fitting. You will also see I fit my 3-pole double throw switch, where I changed the washer to a steel one, which I like a lot more than the standard plastic white one. After that, I made sure the perforated board would fit inside at the top of the pedal, so I had to file it a bit. After that, yeah, you can see here that I double check. After that, I started placing the components. I started out with the biggest one, which is the cap, and I made sure it fit above the potentiometers. And after that, I started laying out the power supply. Now you can see the IC, the LF353. I put it pretty close to the power supply. Normally, I will try to center it on the perforated board, but in this case, one side of the schematics required only the voltage divider and a simple buffer connection between negative and output, while the other side had a lot more things going on, including basically the wall distortion stage and the specific filtering that the Rratt use. You can see I'm laying out now the two tails of filtering attached to the op-amp. You might notice one thing I'm trying to do is keeping the grounds on the sides of the perforated board, way around on the left and right side. That makes it easy to attach all the components that go to ground. Next is gonna come the IC, including the MOSFETs. I was able to leave a bit of gap between the first part of a circuit with center around the op-amp and the second part the center around the MOSFETs, because anyway I have to go to a pot of a tone before coming back for a second part of a circuit. There is nothing much special about my soldering abilities. I just use the LEDs of resistors and caps as much as possible to draw the circuit on the back of the perforated board. One thing I pay attention when laying down the components is to leave some space for the leads the wire that I have to connect to go to the outside components like the ports or input, output jack, etc. You can see like I lay down first the yellow one. The yellow one is the input of a circuit that also give me indication of where I'm going. There is also probably some inside connection that I was not able to do with the LEDs, like there is a piece of red wire that brings the 9 volts around to other part of the circuits I couldn't reach. And then was time to connect everything. You see, I finished to lay out the basic perforated board, and now I'm connecting it to the rest of the pedal. And one thing you are gonna see me doing really soon is double checking the potentiometers, because depending on the manufacturer and if it's a pot that's supposed to be mounted on a PCB or not, sometimes the connections are reversed. So I always make sure to get the right side of a potentiometer. I got beaten many times by making wiring potentiometers the other way around, and so now I'm extra careful about it. Seems like I did lots of double checking and stuff like that, but pretty soon I'm gonna be done with the soldering the main circuit, and I'm just gonna go on to solder the LED and the 3-pole double throw switch, which there is really nothing special about it, so I'm gonna speed up 80 per. You can see, you may notice the resistor for the LED. I just placed it there flying. I will usually put it on the perforated board, but in this case I was worried I didn't have enough space on the board. So at first the pedal didn't work because I made the grounds running here on the sides of the board, and I connected one to ground and the other one I didn't, so nothing was working. I fixed that, but the pedal sounds like shit. So what next step I'm gonna take, first of all I'm gonna add a 3.3k resistor here to ground because I'm losing too much volume from this pot. So by adding a 3.3k I hope to make it behave better, the volume control. After that I'm gonna try and figure out why the tone control sucks up a great deal of volume from the circuit. I would think it should just suck out tone. So I'm gonna probe around a bit around here and see if I can figure out any other changes that could improve this pedal. So I went ahead, I soldered the 3.3K resistor. The only problem is that didn't solve much at all. I then went down a big rabbit hole that took me a long time to come out from. So I'm back after more than a day of debugging the pedal, and of course, as usual, the answer was really silly. So I added the 3.3K resistor here. In the end, not really needed, but I'm just gonna leave it there. And I isolated the problem to the buffer. I had perfect signal before and I had crap after. I started testing this circuit on my main breadboard, and for a whole day I tried to test this circuit and many other circuits, and in the end, as it turns out, it was the breadboard problem. Yes, I don't know what the problem is, but nothing seems to work on this breadboard. So I went back to the first breadboard I ever bought, this tiny one, and I figured out what was wrong right away. And the problem is that because I passed from this JFET to a MOSFET have internal diodes, so probably this resistor was pulling down the voltage too low, and the voltage of our signal here was not passing the threshold of 0.7 volts of internal diode. So everything I needed to do to fix this was simply to add, so I just added a 1 meg resistor there to 9 volts that center the signal, and now I put it right there, above the cap. So now everything seems to work. It's a bit too loud. I could have probably put a little less gain in my added output stage, but it seems to work. So now I'm gonna tidy up a bit this thing. I'm gonna close it and then I'm gonna run a sound test. Here I'm just cutting some wire that was way too long. The advantages of using somewhat long wire is that it makes it easier to debug such a pedal, but then it makes the problem once you have to close it down. On one of my previous videos, a user suggested using a piece of plastic from a PET bottle as insulation material on the back cover of the pedal. I never tried it, so what I'm gonna do, I'm gonna try it now. I'm gonna try to cut up a piece of plastic to glue on this side. Yes, also because it's scrap, but it goes here on the back. Yeah, it was supposed to be a 2kp, but it's not anymore. So I cut up the PET bottle and stick it with a double-sided tape to the bottom of the pedal, and now I'm gonna try to close it, and then we will try if it isolates properly the back. It's a bit tight, but I think I can close it. More of a problem when there is any connection inside. Well, let's see. We are gonna check the Rratt clone through my Greco spool with a JB in the bridge and my usual amp mixed up with a SM57 kind of mic. So, what did you think? I thought it sounds okay for a Rratt. That's how it's supposed to sound, a bit nasty. The modification I made allow it to have a higher volume. On some settings, it gets a bit more crunch from the MOSFETs. Some other settings are a bit too extreme. If I had to make the design better, and what I suggest you could do is lower the gain of the last stage I added. but it works pretty fine as it is. I will put a link to the schematic down below. Other things we learned today is like a MOSFET is not a JFET. They're pretty similar. Most time you can switch them. In this case it didn't work out, but just by adding one resistor I fixed the problem. The hardest thing I had to learn is that my faithful breadboard I used for a few years failed me. I have to confirm this, but I think that probably there are some shorts running perpendicular to the connection lane that makes it impossible to use, and I don't know why, how. I will have to check, and that's about it. As usual, if you like this video, check out more on our channel. Check out our pedals at ZenZeroElectronics.com, and also the t-shirts, which are cool. See you.